Term A in the Lapse rate equation represents differential heating or cooling in the vertical due to diabatic processes. So d gamma dt is equal to minus 1 on Cp d by dz of dq dt. Let's consider a couple of examples to make sense of that. Consider a nocturnal radiation inversion where the temperature increases with height. Because dz is positive, that means that gamma is in fact negative. So now consider the sun coming up and it heats the surface of the earth. So dq dt is positive at the surface of the earth, but the free atmosphere is essentially stationary in its temperature in terms of the shortwave heating. So dq dt is approximately 0. That means that q dot decreases with height, or d by dz of dq dt, or q dot, is less than 0. So minus 1 on Cp d by dz of dq dt is positive, which means gamma is increasing over time, or dt dz is decreasing, becoming more negative. And so we move from a situation over time where we have an inversion and temperature increasing with height to a dry adiabatic layer where the temperature decreases with height. Now think about the example of a cloud at night. The base of the cloud keeps roughly its same temperature, whereas the top of the cloud will cool radiatively. So in this case, dq dt at the base of the cloud is 0 and dq dt at the top of the cloud is negative. So again, d by dz of dq dt is negative, which means over time the lapse rate is increasing, or the temperature at the top is decreasing with respect to the bottom of the cloud. And so you're destabilizing the cloud layer and leading to convective overturning and an increased depth of the cloud. So there's two examples of how term A works.